So welcome everyone to this new video. Now in this video we are going to study about the projectile motion. Now in this channel we generally discuss about the NEET examination as well as your CBSE examination as well as for your ISC examination. This projectile motion is very important for all the examination. Let us discuss on this projectile motion. Now, when you are talking about the projectile mean when you are projecting some particle with a velocity u with an angle phi with the horizontal plane. Now, from your daily life experience, you can say that this particle will go like this way, and after some time it will touch the ground again. Now, this motion is called the projectile motion. Now, in this case, we are going to find out some quantities. First one is the height, second one is the time, and third one is the range. And in the second part of this video, we are going to find the maximum range, or for which angle you will get the maximum range, and the equation of the path. Okay, now to discuss about this projectile motion, you need to have a very good concept about vectors. Okay, now in this case you can see that this velocity is u and it is directed like this, and which is making an angle phi with the horizontal plane. Now I have divided this velocity in two components. One is the horizontal component, that is u cos theta, and one is the vertical component, that is u sin theta. Now the thing is that you can see that the component velocities are perpendicular to each other. They are independent and they will not be affected by each other. As the particle has two velocities, one in the x direction and one in the y direction simultaneously, that is why the particle will move in the x direction as well as in the y direction at the same time. That means it will go in such a way so that it can move in x direction as well as in the y direction at the same time. That's why the path of the particle will look like this. Now whatever displacement distance will be there in the y direction, that is due to the y component of the velocity, and for x direction that will be for the x component of velocity. So that means when you want to calculate some distance or displacement in the y direction, you only have to think about the vertical component of the velocity, and when you want to calculate some distance or displacement in the x direction, that time you only have to think about the x component of the velocity. Here the x component is u cos phi and y component is u sin phi. Now let us calculate the height. Okay, you can see that the particle is going upward direction due to the y component of the velocity. Now at this point the initial velocity was u sin phi, and at the final point the vertical component of the velocity will be 0, because from this point it will start moving downward again. So you can write like this: d square equal to u square minus 2 g s. That means the v will be 0. What is the value of u? Value of u sin phi minus 2 g, here s is the age, so that means you can write h equal to u square sin square phi divided by to g. So this is the formula for the height. So let us find out the time of this flying. Now to get time, you have to think about what is the duration in which the vertical component of velocity u sin phi will become 0. This is the first half of the total flying time. Now the second half will be same, because from 0 with the same influence of force it will again become u sin phi when it touches the ground. That means t up from this point to this point, the required time, plus t down. That means from this point to this point, this is the required time. And you know that this will be t up equal to t down. Okay, now to get the t up, we have to write this formula v equal to q minus gt. That mean p equal to q minus phi divided by g. That is, what is the value of u? The value of u is u sin phi divided by the value of v is 0 divided by g. Now this is the time for the half of the flying. The total timing will be t equal to 2u sin phi divided by g. So this will give you the flying time of this equation. Now let us find out the range. To find out the range, we only have to consider about this horizontal velocity. Now if the vertical component, that means if this velocity is not there, then what will happen? With this velocity, this particle will move on and move on continuously. But as this velocity is present, so after certain time it will touch the ground and this velocity will be lost due to the collision. The range will be, with this velocity, how much distance this particle will travel horizontally in the total flying time. That will be the range. So if you need to find out the range will be r equal to the velocity u cos phi into the total flying time, that is 2u sin phi divided by g. That will be the range. So r will be u sin 2 phi divided by g. This will be the range of this flying. So hope you understood these three things: height, time and range. In the next video we will discuss about the maximum range. That means for which value of phi this particle will cover maximum horizontal distance or will have the maximum range, and what will be the equation of this path. These two things we will discuss in the next video. So hope you understood these three things. See you in our next video. Thank you.